What's the next question? You observe over here. Write a short note on a magnetic dipole moment. Okay. About magnetic dipole moment, we will study in detail in the chapter of magnetism. Don't worry. But little bit you have to understand the about magnetic dipole moment. So I consider a coil of n number of turns. So what n indicates here? Number of turns. Okay, on the coil. Through that coil, if current is flowing, the current in the coil. Okay. And since coil is a rectangular or circular, it depends any whether it is circular or rectangular. It has some area. The area enclosed by the what coil. Okay. So due to current, as you know, when current is passing through that particular coil, magnetic field is produced, and due to magnetic field, there is a magnetic dipole moment is what generated. Okay. The magnetic dipole moment is represented by either you can represent by mu bar. Okay, this is what presentation matlab, symbol. Initially we use m bar, magnetic dipole moment, but in your syllabus, no, in your textbook, it is represented by mu bar, because most of the students are asking, sir, mu stands for refractive index, so shall I use the same symbol? Yes, it is given in your textbook, so you can use this mu bar. You can write m bar also. Okay, but my important thing is what you have to write a formula. Formula is what? Magnetic dipole moment is given by total current. Listen, students. Formula is what? Total current multiplied by area. This is the formula. So what is the total current? Through one turn, how much current is flowing? I. The total turn number of turns are what? N. The total current is what? N multiplied by I. And what is area enclosed? That is A. So what is the formula? You can write mu bar, that is magnetic dipole moment, M bar. But it's a magnitude, na? So magnitude don't write in what? Vector quantity. So this is what formula. Okay. NIA. Okay. N is number of turns. I is what? Current. And A is what? Area. Remember this. So students, when current is flowing, you know that due to magnetic field, there is a force is also generated. So students, torque. Now we have to understand what torque, because there is only formula explanation in the into your syllabus. Nothing too much. Okay. So due to magnetic force, coil is what? Rotating. When something is rotating, torque will generate. Okay. Torque is given by, remember this, torque responsible for the rotation of the coil due to magnetic field. Due to magnetic field is given by, should I remember this formula? Mu bar cross B bar. Okay, this is cross product. Mu bar cross B bar. Remember this formula. This is very important formula. Okay. Or if you know that what is the cross product? Cross product is, what is the formula for cross product? Mu into B into what? Sine theta. If you know the formula, okay. No need to write it in vector form. You just remember the formula in vector format. No need to write the formula of vector product. Okay. So similarly, now there is a small explanation about electric field also, because this chapter is due to the magnetic field, due to electric current. But due to electric current, there is some electric field also. So due to electric field, so remember one more formula: torque responsible for the rotation, because there is also some electric field is also there. So due to electric field, listen students, what is the formula? P bar cross E bar. P bar cross E bar. Now question from the student is what? What is P bar? So what is P bar? You can see the relation between both the formulas. Both the formulas are similar. What is mu stands for? Mu stands for what? Magnetic dipole moment. So what is P bar stands for? Electric dipole moment. Remember this. What is P bar? Electric dipole moment. What is B stands for? Magnetic field or magnetic induction. What is E stands for? Electric field or electric intensity. So there is a similarity in the formula of torque produced in what? What in the coil due to magnetic field or due to electric field. Okay. So this is the explanation about what? Magnetic dipole moment. Okay. This much thing is given into your syllabus. Okay, you can read. I will provide that note, so you can read that particular note. Okay? This much thing is provided. Now I will do the next question. Next question is quite little bit important, but not too much because you can easily write down the answer. But you have to remember the formula. What is the next question? Explain the magnetic potential energy. This is little bit important. You mark as important. Explain the magnetic potential energy of a dipole. We don't want to derive, only we have to explain. Okay. So students, to find out the magnetic potential energy, we are going to take the help of electric potential energy. So students, to define the magnetic potential energy, we will first define the potential energy U of an electric dipole moment, that is P bar, and electric field. So what is the formula? Remember the formula. P bar dot E bar. Okay, and there is a negative sign. Because negative sign indicates what? That energy is in the opposite direction of that electric dipole moment. So this is a formula. Remember this formula. So similarly, I can write the formula for magnetic potential energy of a magnetic dipole moment U bar and due to magnetic field. So listen students, what is P stands for? Electric dipole moment. So electric dipole moment is going to replace by what? Magnetic dipole moment. And here electric field is there. I'm going to replace this electric field by what? Magnetic field. And I will put here minus. Matlab, you understand this magnetic potential energy and electric potential energy having same formula, but due to electric field and due to magnetic field. This dot represent dot product. Okay. So if I apply the dot product, what is dot product of formula? Mu, mu is what? Magnetic dipole moment into B into what? Cos theta. Okay. So this is what formula for, this is capital U. This is what? Magnetic potential energy. Okay, this is the final formula for magnetic potential energy. Now students, as I told you, mu and B. Mu is a magnetic dipole moment and B is what? Magnetic induction. If angle between them is what? 0 degree. What is cos 0? 1. So what is U is given by minus U into B. But if they ask if theta is 180 degree. If theta is what? 180 degree. What is cos 180? Minus 1. So what is magnetic potential energy? U is what? Mu into B. So they told us magnetic potential energy negative means what? Is a minimum. Magnetic potential energy negative means what? Is a lowest, is a minimum. When it is minimum? When angle between them is what? 0 degree. Angle between them means 0 degree, matlab they are parallel. They are parallel. And angle between them is 180 degree. 180 degree means what? One is in this direction, second is in this direction. Matlab what? They are anti-parallel. So remember, one MCQ will come in the exam. Magnetic potential energy is maximum when theta is what? When theta is what? 180 degree. 180 degree means what? This magnetic moment and this magnetic induction are anti-parallel. Okay, remember this. Here they are what? Anti-parallel. Okay, because ये MCQs के लिए आ सकता है. They are anti-parallel and it is minimum. Magnetic potential energy is minimum when theta is 0. Agreed. But what do you mean by that? Magnetic moment and magnetic induction are what? Parallel. Okay, this is a simple theoretical theory about what? Magnetic potential energy. Hope so you understood the theory. Please